All right, so we are going to be finding the area of sectors and finding arc length, but just a quick little warm-up. What is the area of a rectangle 12 inches long and 6 inches wide? If you recall, the area formula for that is length times width. So that would be 12 times 6, which is 72 inches squared. What is the area of half the rectangle in number 1? Well, our area was 72. And if we're doing half, we can either divide by 2 or multiply by 1/2. And if we multiply by 1/2, you notice it still ends up being 72 divided by 2 when you multiply straight across. And that gives you 36 inches squared. What is the area of 3/4 of the rectangle in number 1? Again, we have that 72 over 1. And when you're looking at area of is your magical little word to multiply. So we are multiplying by 3/4. And just remember, I didn't do it with number 2, but you can cross simplify. So if you see a number in the top that can be divided by a number in the bottom, that's totally fine. So 72 and 4, 72 can actually be divided by 4 because it's 18. So 72 becomes 18, and that 4 divided by 4 just becomes a 1. So 18 times 3 is 54 inches squared. What is the area of a circle with a radius of 8 miles? That formula, in case you forgot, is pi r squared. So we're going to have pi times 8 squared, which would be 64 pi. And as a decimal, that would be 201.06 miles squared. And then what is the area of half a circle with a radius of 6 kilometers? So again, pi r squared, that'd be pi times 6 squared, which would be 36 pi. And I'm going to worry about the half now. So because I have that 36 pi, I'm going to multiply by 1/2 or divide by 2, depending on how you want to look at it. This 2 can go into that 36 18 times. So 36 becomes 18, 2 becomes 1. And then we have 18 pi, which as a decimal is 56.55 kilometers. So actually getting into this, sectors of circle is a region bounded by 2 radii of the circle and their intercepted arc. So if you notice in the picture, it really is just like you take a slice of it. And in order to find the area, it is pi r squared times m degree divided by 360. And so if you look at this equation, that r is the radius of the circle. And this entire part of it, this pi r squared, is actually area of a circle. So if we were to just have area of the circle, then we'd be looking at the full area of the circle. When we have this m degree divided by 360, the m degrees is actually your arc degrees. And so if your arc is, let's say, 30 degrees, 30 divided by 360 is 0.083 repeating. And so that's just saying that we're taking the area of the circle and then multiplying it by whatever percentage of the circle we have based on that arc size. So just in side note as well, because this is area, your units will be units squared as well. Oops, squared. So moving on, we want to find the area of the sector and then give our answers in terms of pi and round to the nearest hundredth. So with this one, we have area. It is your circle area times your arc divided by 360, because again, that 360 is your circle. So in this case, my radius is here. And that 131, remember, central angles have the same measure as their arc. So we're going to be plugging in 12 and 131. Okay, and when we do that, we would have 144 pi. And honestly, I probably wouldn't even write this step. I'd probably just let the calculator do all the work for me. Because when you do that, you end up getting 52.4 pi, or as a decimal, 164.62 meters squared. In case you're curious, it was 619, so I did have to round a little bit. If you really want to, in where you have the 131 divided by 60 or 360, that is, if you would rather write it as a decimal, you can. But again, I personally would just let the calculator do most of the work in this part and probably skip that line right there. So looking at the next one, again, same thing. The radius of this circle is 5, and our arc measurement is 25 degrees. So our formula is area of a circle times the number of degrees we have divided by the number of degrees in the circle, which is 360. So we are plugging in 5 for R and 25 for M because it's 25 degrees. Again, I'm letting the calculator do the work. So I would type it as 5 squared times 25 divided by 360, and that gives you 1.736, so that'd be 1.74 pi, or as a decimal, that would be 5.45 feet squared. And again, in case you're curious, this was 454, and this one over here was 736. Okay. Looking at the next one, we have our radius is 1, and our measurement is 90 degrees. So, because I have that, again, the formula, it's not a bad idea just to write the formula so that it kind of forces you to memorize it. So pi r squared is a circle, m is your degrees in the arc. So my radius is 1, and my degrees in the arc is 90. And so then, again, calculator does most of the work. If you really want to, a part of me wants to make this 90 over 360 a 1/4. But again, you don't have to. Because then you get 0.25 pi. Oops, and my point is really close to that 0. And then I erased a bunch of it. Oops. Or when you multiply by pi, it becomes 0.79 meters squared. Okay. A windshield wiper blade is 18 inches long. To the nearest square inch, what is the area covered by the blade as it rotates through an angle of 122 degrees? So if you think about a windshield wiper, it goes like this, and it goes like this, and it does kind of make a little circle. So really, if you were to draw like it on a circle, it's almost like that. So still using the same formula, pi r squared times m over 360. And so our radius is 18 because that's how long the windshield wiper actually is. And then we have 122 divided by 360. So again, in the calculator, I would do 18 squared times 122 divided by 360. And that would give me an area of 109.8 pi. And then I multiply the pi in to make it 344.95 inches squared. Okay. In the same way that the area of a sector is a fraction of the area of the circle, the length of an arc is the fraction of the circumference of the circle. So if it's a fraction of the circumference of the circle, now my formula has the circumference formula times the arc measurement again. So it's that arc measurement helps you figure out what fraction of the circle do you have, and then you're just multiplying it by the circumference formula. And again, this is the circumference formula. Circumference. So, since this is like circumference, your units are just going to be regular old units, nothing special. So, going into it, we want to find the arc length, and we're going to give our answer in terms of pi and round to the nearest hundredth. So if I want to find the length of arc FG, it is 2 letters, so I know it's a minor arc, so it's going to be less than 180 degrees. So then my arc length is my circumference formula times the fraction of the circle I have, which is my degrees divided by 360. So then my radius in this circle is 8, and my degrees is 134. So then, again, calculator's doing all the work. 2 times 8 times 134 divided by 360, and that gives you 5.96. Don't forget your pi. Or if you multiply the pi in, it is 18.71 centimeters. And again, this is just a length, so it's just the plain old unit. Find each arc length. Give answers in terms of pi and round to the nearest hundredth. An arc with measure 62 degrees and a circle with a radius of 2 meters. So again, oops, that's probably help if I used a pen. Length is your circumference formula times your fraction of the circle, which is your arc measurement. So since our arc is 62, we're going to be plugging that in for m, and our radius is 2, so I'm going to plug that in for r. Okay, so then in the calculator, 2 times 62 divided by 360 gives you 0.69 pi. Or when you multiply the pi in, it is 2.16 meters. Okay. Next one, we're going to find the arc length. Again, notice it is GH, so it's just this little minor arc again. And our radius is 6, and our degrees is 40. So length is 2 pi r times your degree measure divided by your total degrees. So 2 times pi, our radius is 6, and our measurement of our arc is 40 divided by 360. So on the calculator, 2 times 6 times 40 divided by 360, which would give you 1.33. Then you throw your pi back in there because we haven't multiplied it in yet. And then when you do multiply it in, it is 4.19 meters. So that is actually pretty much the gist of it. If you have any questions, feel free to ask, but it really is just those two formulas and being able to apply them.